In this video, I will explain how to construct a topology on a set given a set of mappings into the set. This is the so-called final topology. So the video wants to explain what the final topology is. And so the construction starts with a set X, we call it, which doesn't have any further structure. And then we want to give us a map F or a family of maps Fi actually from some topological spaces. So where Ti is the topology, so those are topological spaces. And we want these maps to map from Yi into X. And so X doesn't have a topology yet, but the construction will basically provide a topology which somehow depends on these mappings Fi. So I can be from some index set, which doesn't necessarily have to be finite. This is actually irrelevant for the construction, what the index set is, as long as we have as long as we have these mappings from topological spaces, and we have a bunch of them. Okay, and so what we want to construct is a topology T, and let's call this topology final for the final topology. It's with respect to the Fi, and this will be a topology on the set X, and we declare all the sets U, subsets of X, to be open or being part of the topology if the pre-image of this set UI is open or an element of the topology for all I in the index set. Okay, so basically we say we have these mappings into the space X and we want to test whether sets are open. They are open if and only if the pre-image under every one of these mappings Fi is open. And so the small lemma we basically need is that the final topology is a topology on X, right? And so basically we have to check a few things. So first of all, why is X as a subset of itself? Why is this in the final topology? Well, and if we take the pre-image under one of these mappings, we see that we get exactly Yi because this is a map. So this holds for all I in I. And since the Ti are topologies, we know that Yi is an element in Ti. Therefore, X is in the final topology. And similarly, if I take Fi of the empty set, this is the empty set, and this is in Ti for all I. Therefore, the empty set is in the final topology. And we have at least two required sets which are in there. Now we need two more things. We need that if family Uj, J and J, if this is a subset or if all of the members of this family are contained in the final topology, then we also want to see that the union of the Uj, whatever it is, that this is an open set, and we can test this by applying or computing the pre-image of this guy. And now we know basically because pre-images are very nice. Or taking the pre-image under mappings is a very nice operation that this commutes with the union. So we can basically take this inside of the union. And so now these guys, the pre-images of these, because the Uj are in the final topology, they are all in Ti. And since Ti is a topology, then also the union is again inside of this by one of the basic requirements for topology. And we see that the union of the Uj is in the final topology if every single one of the uj is in there. And similarly, if I have u and v elements in the final topology, then since the pre-image is compatible with taking intersections, I see that also, well, since the pre-image of U and the pre-image of V is in is in TI, then also this guy is in TI, because U and V were in the final topology, and since this holds for all I, this means that the intersection of two sets is in the final topology. Okay, and this finishes the proof. So the final topology really is a topology. And so where did we, for example, in the course on Lie theory, use the final topology? This construction can be used, for example, to put a topology on the tangent bundle Tm of a smooth manifold, or actually of a differentiable manifold, but it doesn't matter. And we also use it for the special case of a quotient topology, where we have basically a group, and we are quotienting out a subgroup. So this map was QGH, and where we send a group to its coset. So this is the so-called, or what we would call the quotient topology. Is the final topology. Oops, sorry. With respect to the family consisting only of this quotient or of this special map QG. Okay, so this is the final topology.